Hi guys, this is the third video for AP exam review number 2, more probability and random variables. And what we're going to take a look at now is an AP problem. And this AP problem, you can see this table, so it looks similar to what we did in previous problems. There's also going to be the need to use the normal distribution here. So we'll take a look at that. It'll be a nice refresher. Let's take a look at what the problem says. A charity fundraiser has a spin the pointer game that uses a spinner like the one illustrated here. Now there are 10 equal sections in this and equally likely. So a donation of $2 is required to play the game. For each $2 donation, a player spins the pointer pointer once and receives the amount of money indicated in the sector where the pointer lands on the wheel. The spinner has an equal probability of landing on each of the 10 sectors. Now, they're doing this for charity. So when you play for your $2, you could win nothing, you could win $1, or you could win $10. But we're going to look at it from the perspective of the charitable organization. If you win nothing, they make $2. If you win $1, they make $1 because you gave them 2 to play and you gave them 1 back. I'm sorry, they gave you 1 back, so they make $1. And if you hit the jackpot $10, the charity makes negative $8. They lose $8 because you played for 2, you won 10, your net gain was 8, which means the charity's net loss was 8. So let's figure out the probabilities of each of these events occurring. So for $2, that would mean that the charity would get $2, which means you lose, you get nothing. There's 1, 2, 3, 4, 5, 6 places in which you get nothing. There's a 60% chance that the charity makes $2 on your play. How about $1? There's 1, 2, 3 locations where the charity makes $1 because you played for 2. You won 1 back, and the charity makes 1. That's a 30% chance because there's 3 locations on the spinner, and there's a 1/10 chance of hitting the jackpot, and that's where the charity loses $8. Okay, so the next thing is, what is the expected value of the net contribution to the charity for 1 play of the game? So you know how to do this. We go to our calculator, we go to stat edit, and we're going to put in 2, 1, and negative 8 into the possible outcomes, and with a probability of 2 as being 0.6, $1 as being 0.3, and they lose $8 as 0.1. And if we go to stat calc 1 variable stats, L1, L2, good, 70 cents. So for part B, for each play of the game, the charity can be expected to win 70 cents, okay? Part C. The charity would like to receive a net contribution of $500 from this game. What is the fewest number of times the game must be played for the expected value of the net contribution to be at least 500? Now, if they're making 70 cents per game, 70 cents for 1 game, $1.40 for 2 games, so what you could do to find out how many games they would expect that the people have to play would be 500, which is what they want to win, divided by 0.70, and that turns out to be 714.28, which rounds up to 715 games. If this game is played 715 times, the charity can expect to make $500, okay? Part D, this is where we're going to need a normal distribution. Based on last year's event, the charity anticipates that the spin the pointer game will be played 1,000 times. So they think that this game is going to be played 1,000 times. The charity would like to know the probability of obtaining a net contribution of at least $500 in 1,000 plays. So they're hoping to make at least $500. The mean and standard deviation of the net contribution to the charity in 1,000 plays of the game are $700, and that's the mean, and $92.79, that's the standard deviation. Remember, just because the charity would expect to make $700 from 1,000 plays doesn't mean it will. There's some variation, and the standard deviation is 92.79. So use the normal distribution to approximate the probability that the charity would obtain a contribution of at least $500 in 1,000 plays of the game. So here's how we're going to do this. Here's the normal distribution. The expected value for 1,000 plays is $700. They want to make at least $500, which means that this area here will be the probability that they make what they want to make, at least $500. Okay, in your calculator, you would go to the normal CDF, you'd put in the low value of 500, the high value of infinity, and you would do your mean of 700 and your standard deviation of 9279. Let's see what that gives us. If you go to your distribution, second vars, normal CDF, you're going to go from 500 up to E99, which is infinity, E99. Remember, to get to the E, you do second and the comma. And you got to put in the mean. The mean here is 700, and the standard deviation is 9279. And let's see what that yields, 90.9844. That means they can be pretty sure they're going to make at least $500 with 98% of the time. There's going to be about 1.5% of the time where they're going to fall short of their goal. Okay, do your homework. I'll see you next time.